Assalamualaikum and hi. So now we look at example 5 from chapter 9. So what we have in the question is the displacement x of a particles undergoing simple harmonic motion is given by x is equals to phi sine 20 pi t. So given in the question is the equation for displacement of a simple harmonic motion object where x is in centimeter and t is in second respectively. What is the maximum speed of the particles can be achieved? So the question asks to find V maximum. Okay, however, given in the question is the displacement, and we know from the displacement we can derive and get two equations for our velocity. So x is equals to 5 sine 20 pi t. To get V, we have two equations. If you still remember, we have watched in video 9.1 derivation of velocity's equation. You have to differentiate your x to get the equation of velocity, where if I differentiate, I will end up with 20, no, that is pi here, omega, 20 pi 5 cos 20 pi t. So this is my one equation for velocity, 20 pi t. And then another equation is a long one. You have to use the identity and everything, and then you will end up with plus minus omega square root a square minus x square. Okay, so we have two equations here that you can use to find your velocity. Alright, the question asks to find maximum speed. So to find maximum speed, we are looking for the maximum value of our velocity here. Alright, to use this first equation, you have to know the t so that you can find your v. However, we do not know at what time does the maximum speed occur. We do not know. To use the second equation, omega, you can get from the question as you compare the equation with with general equation. So our general equation here is V is equals to A omega cos omega t. So from here, I can deduce that my omega is 20 pi. So omega is sorted. Amplitude is, this is our amplitude because this is A omega, where your omega was 20 pi tadi. So A kamu adalah 5 basically, which is A here, 5 here. And then X, you have to know the X, which is the maximum, you have to know the displacement at maximum speed so that you can find the speed. However, berdasarkan pemahaman kita given in the terminology earlier, the fixed point X is equals to 0, a point where the velocity is a maximum. Okay, so your velocity is maximum occur when your x is equals to 0. Okay, maximum velocity boleh dicapai bila displacement kita adalah kosong. You will also encounter a supporting information for this part here when you look at 9.2 graph of simple harmonic motion. Okay, so for now kita kena faham V maximum akan occur at displacement kita sama dengan kosong. So now I'm going to choose this equation number 2 to find my V maximum, as I know my x is equals to 0. Dekat sini saya tak tahu t, sebab tu saya tak boleh guna equation yang pertama ini. So I'll have V max. Sebab saya dah tulis siap-siap V max, saya akan jadikan dia. Since the question only wants to know the speed, not the velocity, so the direction doesn't matter here. Saya nak neglect plus minus dia. Omega A square minus X square. Okay, X is equals to 0 sebab V maximum. Alright, and then kita akan dapat omega kita adalah 20 pi sed A square kita adalah 5 square minus 0 square. And then tekan calculator, you should get 314.16. Okay, ini adalah velocity. Unit untuk velocity adalah displacement divide by the time. Betul tak? Displacement kita dalam unit centimeter, so it will be centimeter per second here. And then next, the question asks to determine the magnitude of the velocity and acceleration when the particle is 3 cm from the equilibrium position. So sekarang kita nak magnitude of the velocity and acceleration when the particles is at 3 cm from equilibrium. So soalan B dekat sini adalah kita nak tahu, dia kata cari V dan juga A when X is equals to 3 cm. So maksudnya dia dah bagi X adalah 3 cm. So I'm going to use this equation now. Sebab apa yang kita tahu adalah X, kita nak cari V. Kalau nak guna equation ini sama, T is unknown. Okay, remember dalam video saya cakap, nanti bila kita jawab soalan, kita akan tahu when to use which equation. Equation ini sesuai diguna bila T yang diberi. You know your T, you want to find your V, maka kita guna equation ini. Because unknown dia dekat sini adalah T dan juga V. Whereas untuk equation ini, omega dengan A boleh dapatkan daripada soalan. If you know your X, you can find your V. So kita akan guna equation ini bila X diberi. So dalam case ini, X yang diberi iaitu 3 cm. So I'm going to use my second equation iaitu V is equals to plus minus omega set A square minus X square. Alright, so by now kita dah tahu when you compare this equation to general equation iaitu A sin omega T, saya tahu my A here is 5 cm and I know my omega is 20 pi radian per second. So selalunya better start daripada comparing dulu untuk dapatkan constant term, benda-benda yang constant dulu daripada soalan supaya senang untuk kita kira. So omega here becomes plus minus 20 pi. Set A kita adalah, is my A tadi 5 cm cm minus X saya adalah 3 cm. Alright, and then press your calculator, dapatkan jawapan sebanyak 33 cm negative 1 here. Okay, same goes to your A. Untuk A kita ada dua equation juga. If you can recall, kita ada derive. Yang pertama adalah A omega square, sin omega T, ataupun kita ada A is equals to negative omega square X. Okay, to use the first equation sama, kena tahu T boleh dapatkan A dekat sini. Okay, kena tahu T untuk dapatkan acceleration. Equation kedua adalah if you know your X, you can automatically get your acceleration here. So saya akan guna equation yang kedua. A is equals to negative omega square adalah 20 pi square. Remember, negative itu bukan square, omega yang square. X adalah 3 cm given in the question. And then tekan calculator, you will end up with negative 11.84 times 10 to the power 3 cm negative 2. Alright. Okay. So, kena pilih equation yang bersesuaian dekat sini. And then finally, determine the speed of the particle at T is equals to 0. So, dia suruh cari V bila T sama dengan kosong. So, sekarang kita bolehlah guna equation yang V itu, iaitu V is equals to A omega cos omega T dekat sini. Sebab soalan bagi T sama dengan kosong, dia suruh cari V berapa. So, you're going to use equation that has something to do with the time here. Okay, so kita tahu V adalah, A kita adalah tadi berapa? 5, omega adalah 20 pi, cos omega T, omega here is 20 pi T. And as you can see, sebenarnya kita dah ada dekat sini sebenarnya. This is what your equation is all about. 100 pi cos 20 pi, dia kata T adalah kosong. And then press your calculator, tekan calculator, pastikan tekan betul-betul. Remember, your calculator must be in a radian mode. And then darab dengan 100 pi dekat sini, you will end up with 314.16 cm per second. Alright, I'll be good here.